Right, guys, here we have a triangle, and we're asked to find the length of YZ. So I'm like, okay, this triangle, it's not a right angle triangle, so let's see if we think of our flow chart. We have a triangle. If it's a right angle triangle, and we can have non-right angle triangles. If you have a right angle triangle, you can either use Pythagoras, or you can use trigonometry. If you have a non-right angle triangle, you can either use the sine or the cosine. Alright, sine. So I think straight away, I have a non-right angle triangle. And then I have to either choose the sine or the cosine. Remember, I always check for the sine rule first. I use the sine rule if I have pairs. Well, let's have a look. Well, I want to find this pair. Do I know this pair? No, because I'm missing this angle. Do I know this pair? Well, no, because I'm missing this angle. Is it possible to find one of these angles? No, because angles in a triangle add to 180. We have 79. If I had this angle here, I could find this angle here. But unfortunately, we don't have pairs. So in the situation where there's no pairs, you just straight away just say, all right, we're going to use the cosine rule here, okay? So the cosine rule is a squared equals b squared plus c squared minus 2bc cosine a. So what we're going to do, guys, is we'll just make up some letters. So here we have x, y, z. I'm going to make up my own letters. And in the cosine rule, the a squared is the unknown. So let's always call the unknown a, if you can. So find length of yz. So y to z, we're going to call this side a. And this is angle A, so we can cross out x, y, z. We don't need that anymore. We can call this B and side B. And we'll get rid of this. Call this C, and this is side C. Okay? And we're just going to fill it out, alright? So A squared, well, A is unknown, so we'll call it x squared equals B squared, so 8 squared, plus C squared, 10 squared, minus 2 times B, which is 8, times C, which is 10, times cosine A, 79. All right, just like that. Let's simplify that. Well, 8 squared is 64, plus 100, minus, we can simplify all of this in one go. So 2 times 8 is 16, times 10 is 160, so 160 cosine 170, cosine 79. We'll simplify this even more. X squared is equal to 64 plus 100 is 164 minus 160 cosine 79. Now, at this point, people make a really classic mistake. They think, okay, we can do 164 minus 160 to give us, well, 164 minus 160 is 4, and then cosine 79. We cannot actually combine these, because this is a number term, this is a cosine term, so these aren't like terms. So all you're going to do at this point is now just plug this into your calculator. 164 minus 160 cosine 79. Let's put it all into your calculator, okay? Now, if x squared is 133, to find x, you're just going to square root 133.47. And that will give us our answer. 11.6. And that's your answer, 11.6. So what you do, very similar. So basically, if you have a question about non-right angle triangles and you don't have pairs, like in this question, we were looking for this pair, we didn't know this pair, we didn't know this full pair. Therefore, we're like, all right, we can't use the sine rule, let's use the cosine rule. You plug in your own A, B's, and C's. Simplify. When you get to this part, make sure you don't do 164 minus 160. Just put this whole thing into your calculator, okay? And I gave me 133, and just see what came out, all right? So you can try this question by yourself. See if you use the sine rule or the cosine rule. Next question: calculate the smallest angle in the triangle. All right. Well, first, it doesn't really tell us which angle we're trying to find. We just have to find the smallest angle. Well, a little clue, guys, is the smallest angle is always going to be the opposite of the smallest side, okay? So the smallest side is 9, therefore the smallest angle will be this one here. If we're trying to find the biggest angle, it'll be opposite the biggest side, so it'll be this angle here. All right, so we're trying to find this angle here. And then let's use our flowchart. So let's get it from the last page. Oh, oops. Right angle triangle, Pythagoras. So I think, okay. First of all, I have a non-right angle triangle. Let's look for pairs. Well, I'm looking for this pair, but I don't know this full pair, nor do I know this full pair. Is it possible to find this angle? No. Is it possible to find this angle? No. Therefore, we're going to use the cosine rule. So let's write out the cosine rule. A squared equals b squared plus c squared minus 2bc cosine A. And since and in this case, we're trying to find an angle. So that's going to be angle A. All right? Because we're trying to find out this section here. So I'll call this A. We'll call, and this is side A, I don't know, B, and then C. All right? And let's go ahead and fill this out. So A squared, so 9 squared, plus B squared, well, B is 13, so 13 squared, plus C squared, 17 squared, minus 2 times B, so 2 times 13, times 17, times cosine A, which we don't know. So I'll leave it as cosine A, or you can do cosine X. Let's just do cosine A. Let's simplify that. So 9 squared is 81, equals 13 squared is 169, plus 17 squared, which is 289, minus 2 times 13 times 17. 442 cosine A. Simplify even more. 169 plus 289 is 458 minus 442 cosine A. As before, don't make it a classic example of subtracting 458 by 442 because these aren't like terms. This is a number term. This is a cosine A term. So you do not want to write 458 minus 442 is 16 cosine A. That will be wrong. What you're going to do now is we're going to use a little bit of algebra. We're trying to find cosine A. So we want to isolate that. Well, first things first is we can get rid of this 458. 458 is positive 458. So we're going to subtract 458 from both sides. Minus 458. So 81 minus 458 is negative 377 equals, this cancels out. We're left with negative 442 cosine A. Well, we're trying to find what cosine A is, so we have to isolate it. Well, cosine A is being multiplied by negative 442. So we're going to divide by negative 442. Divide this side by negative 442. So negative 377 divided by negative 442 is 0.852. The 442's cancel out, equals cosine A. And like when you're doing trigonometry or the sine rule, whenever you're trying to find a missing angle and you've got cosine A, you have to do the inverse of that. So cos inverse 0.852. And let's see what your answer is. 0.852, 31.6 degrees. And that's your answer. So same thing. In this case, we're trying to find big A. So we're trying to find this. Plug in your values, simplify. When you get to this part here, you do not do 458 minus 442 because this is a number term. This is a cosine A term. We're going to have to isolate cosine A by minusing 458 from both sides and then dividing both sides by 442. Then you do your inverse to find your answer. So you can try that question by yourself. Last one. So a tricky question. Two ships, A and B, leave a port at 11. A travels on a bearing of 80 at a speed of 25. B travels on a bearing of 152 at a speed of 20. Work out the distance between A and B at 2 o'clock. So I want to find the distance between A and B. Boom. So I'm going to draw that line. Well, what do I know? Let's read this question. So that's our unknown. 2 ships leave a port at 11 o'clock. So I'm guessing this is the port here. All right. A travels on a bearing of 80 degrees. Well, so from the port, we have our north line. From the north line, we always go clockwise to A. This must be 80 degrees. And B travels on a bearing of 152. So from the north line to here is 152. So if we know this angle from here to here is 152, and from here to here is 80, how can we find this angle here? I'm going to make this highlighter skinnier. How can we find this angle here? Well, we can do 152 minus 80. So that's going to be 72. So we can say, okay, cool. I can just say instead, this angle must be 72. Now, A travels on a bearing of 80 degrees at a speed of 25 kilometers per hour. Now, the ship leaves the port at 11. It arrives at its destination at 14. That's 3 hours. All right? And if it travels for 3 hours at 25 kilometers per hour, so in 1 hour it travels 25 kilometers. For 3 hours, we can do 3 times 25 to give us the distance it traveled. So the distance of ship A has traveled is 75 kilometers, okay? And then B, it's traveled also for 3 hours at 20 kilometers per hour. So 20 kilometers per hour for 3 hours. So in 1 hour it travels 20, 2 hours is 40, 3 hours is 60 kilometers. So this distance is 60. Now let's draw our triangle out separately. All right, so we know this angle here is 72, this is 75, this is 60, and we're trying to find this here. So I'm like, okay, cool. We have a non-right angle triangle, so we have the cosine rule or the sine rule. So let's check for the sine rule first. Let's look for some pairs. Well, I'm looking for this pair. Well, unfortunately, I don't know this pair. Nor do I know this pair here. So I'm like, boom, we're gonna use the cosine rule. So a squared equals b squared plus c squared minus 2bc cosine a. So we have to start labeling. So let's call this side A, angle A, side B, angle B, side C, angle C. And let's plug it in. Little a is x, so x squared equals b squared, so 60 squared, plus c squared, 75 squared, minus 2 times b, so 2 times 60, times c, 75, cosine, and a is 72. Let's simplify this, so 60 squared is 3,600, plus 75 squared is 5,625, minus 2 times 60 times 75 is 9,000 cosine 72. Let's simplify even more. So 3,600 plus 5,625 is 9,225 minus 9,000 cosine 72. We can't subtract 9,225 by 9,000 because this is a number term. This is a cosine 72 term. So all you're going to do is just plug this whole thing into your calculator, okay? So 9,225 minus 9,000 cosine 72 is going to give you 6,443.84. Then that's squared, so we're going to square root our answer to find our answer. So the square root of 6,443 is 80.3. So we can say, okay, this length here is 80.3. Let's do this question on the next page, actually, part 2 of it. Let's make it bigger as well. So this was 80 degrees. This angle here was 152. So therefore, the remaining section must have been 72. This line here we found out was 80.3. Oh, 80.3. 25 kilometers per hour for 3 hours. That gives us a total distance of 75. 20 kilometers per hour for 3 hours gives us a total distance of 60. So we can draw our triangle out separately. Nice and big. 72, 75, 60, 80.3. Work out the bearing of B from A at 2 o'clock. So here's A, here's B. Work out the bearing of B from A, and here's the port. Now remember, when you do bearings, the key word is from. Where is the bearing coming from? It's coming from A. That's so important we understand the vocabulary. So from A, we're going to draw a north line, all right? Because where the bearing's coming from, you're going to draw a north line. And then bearings are always clockwise. So from A, we're going to draw a line until we hit the line of B. So we want to find this angle over here, okay? So from A, find the bearing of B. So we go from A clockwise until we hit the line of B. So that angle's there. And then I think, all right, well, how can I find this angle here? One second, I know this is also 80. So I'm like, okay. Well, first things first, I know that these two north lines are parallel lines. And do you guys know what the allied angle rule is, the C rule? If you have two parallel lines and they form a C shape, like this, you can see the C, the angles inside a C add to 180. So if this is 80, so here's our C. If this is 80, this must be 100, because angles inside a C are add to 180 degrees. So this is 100. And then maybe I could find out what this angle here is. All right, so let's draw this triangle out separately, because this is a little bit messy. A, B, P. This is 72. This is 75. This is 60. This is 80.3. And I want to find out this angle here. So I think, okay, it's a non-right angle triangle, so I can use the sine or the cosine rule. Sine rule, we use pairs. Well, I'm looking for this pair. Oh, and look, we have this pair. So two pairs, we can use the sine rule. So, like as always, you can ignore the letters they give you on the question. Make up your own A, B, and C. In this case, A can stay the same. So let's just keep this as B. B, B, and then side C, C. Instead of port, we're going to replace it with C. So, what's the sine rule again, guys? Well, it's A over sine A equals B over sine B equals C over sine C. But when we're trying to find a missing angle, we flip it. So it's going to be sine A over A, sine B over B, sine C over C. So we're trying to find a missing angle, so we're going to put the angles on top. So sine A over A equals sine B over B equals sine C over C. So, and we're going to be using A and C. So we don't need B in this one. So sine A, so angle A is X over side A, which is, so sine X over side A, which is 60, is equal to, we're not using the B, sine C, angle C, which is 72, so sine 72, over side C, 80.3. Now, I'm trying to find sine X, so I want to isolate that. Well, it's being divided by 60, so I'm going to times both sides by 60. That cancels out, so it'll be sine X equals, I just put this in my calculator, so sine 72 divided by 80.3 equals something times 60, which is 0.71. Then to find a missing angle, make sure you do the inverse. So the inverse of sine, 0.71, is 45.3. So this angle here is 45.3. So this angle here is 45.3. And I know in a full circle, the angles in a full circle add up to 360. So to find this angle here, I can do 360 minus 100 minus 45.3. And that will get me my answer. So 360 minus 100 minus 45.3, which is 214.7 degrees. And that would be your final answer.